In this video, we're going to talk about exponents. Specifically, we're going to talk about the properties. So when we add exponents, multiply, divide, what happens when you have an exponent raised to a power, perfect squares, and talk about some vocabulary. So to start with, we're going to look at some key terms. The first key term we're going to talk about is a number called the base. Okay, so the base is the number or variable associated with an exponent. Okay, so 2x squared, the number associated, or the number or variable associated with the exponent is x. So x becomes our base. X to the nth, that is our base. Okay. The exponent obviously is this. That's the exponent. Now, what you might see is you might see an index or an indices. That's the British term for exponents, is they call them indices. Okay, so let's look at this down here. So x to the nth, this is the index. Okay, we're used to just calling it the exponent, but the British specifically call that out, and that's the index. So I want you to be aware of that. Okay, if we look at adding exponents, okay, so when we add exponents, right, and remember adding includes subtraction, you follow the order of operations, okay, and you can only add variables if they are both the same. Okay, so if we look at our two examples that I have called up here, you've got x squared plus x squared. Well, they have the same base and the same index. So that means we can add them together to get to 2x. If we look at our other example we have called up, x squared plus 3x, x's, so this is same base, but different index. Okay, so that does not equal x to the fifth. Now, if we're just looking at regular numbers, when you have it, you're not going to add 7 to 2 and do 9 to the fifth, right? You're going to follow the order of operations. So you're going to do exponents, 7 squared and 2 cubed, and then add them together. So that's adding exponents. Now, we have negative exponents. Okay, so when we're dealing with negative exponents, if the base and exponent are not 0, okay, so what that means is we don't have 0 raised to a power, or we don't have x raised to the 0 power, right? If we don't have that, then what you do is you take, so if we have x to the negative nth power, what that means is you rewrite as a fraction. So this is the same as 1 over x, and the n is now positive. Okay, this will become more important as you get later in your math career and you get into calculus, because we rely heavily on the exponent rules. Okay, so we can look at these two examples here as well and see how it works out. So if we look at the second one, we have 3m to the negative second power. So that moves as a fraction and as a positive exponent. So that is your negative exponent rule. Product rule is probably the one you remember or at least revert to, right? So this is when you're multiplying. So when we have x to the nth times x to the m, right? If the bases are the same, you can add the exponents. So we have x to the n plus m power. Okay, that's the product rule. When you multiply, you can add exponents. So if we look at our example over here, okay, We have 3x to the fourth y to the fifth times 2x to the fifth y squared. So our like bases, so we can add the exponents. And again, the same like bases, add the exponents. So again, product rule says when you multiply like bases, add the exponent. Next, we're going to look at the quotient rule. So the quotient rule is dividing. Now, there are two different ways we can think about this. Okay, so we can think if we have x to the m divided by x to the n. Okay, so if you're dividing and the bases are the same, you're going to subtract. So this is going to be x to the m minus n. Okay, the other way to think about this, so the other option would be to think of it like this. We're going to take x to the m divided by x to the n and convert it into x to the m times x to the negative n, right? That uses the negative exponent property we just looked at. Now, in the product rule, we saw that if bases are the same, add the exponents, so we get x m plus negative n, which if we go back and look over at what we had before, remember subtraction doesn't exist, you're going to add the opposite, and then those two are indeed the same thing. So that's the two different ways you can think about the quotient rule in dividing exponents. So again, if we look at a specific example here, we have x and x, so they are like bases, so we're going to subtract the exponents. So we're going to have x to the 4 minus 2, which is where we get x squared. And then we're going to do the same thing. We're going to have y 5 minus 7, which gets us negative 2, which puts us right there. So that is the quotient rule. Next, we're going to look at one of my favorites just because it's power of a power. Okay. So what that means is when you have an exponent raised to an exponent. So we have x to the n raised to the m power. Okay. So what that means is you just multiply them by each other. So this becomes x to the m times n power. Now there's one thing to be careful of, and we'll see that in our specific example over here. Okay, so remember with parentheses that what's outside has to happen to everything inside. Okay, so when we have 3x to the fourth squared, what that really means is we have 3 squared times x to the fourth squared. Now be careful doing that, because what I am not saying is x plus 3 squared is the same as saying x squared plus 3 squared. That is not the same thing. That's not what we're doing. Okay. If you want to think of it a different way, we have 3x to the fourth times 3x to the fourth. And if you work these through, you're going to get the same thing. So let's do just that. So we get the 9, and then 4 and 4 make 8. So that's how power of a power works. This is the one that always confuses people because it just intuitively doesn't make sense, is this is the 0 power rule. So this says any base raised to the power of 0 has the value of 1. Okay, so anything x to the 0 power is always 1. Always, always, always. Anything to the power of 0 is 1. Okay, and there's a couple different reasons for that. You can Google them if you want to know in grave detail. But the long story short is it follows the pattern, right? Mathematics want everything to make sense. So let's look at 2 cubed is 8. 2 squared is 4. 2 to the first is 2. 2 to the 0 power. We'll leave that as a question mark for right now. And then you have 2 to the negative first is 1/2. 2 to the negative second is 1/4. So if we look at this and follow the rule, 8 to 4 is -4 minus 2. So this we divide by 2. So if you continue that, you divide by 2. So this becomes -1. So then this mystery becomes 1 to get to there. This becomes divide by 2 to get -1/2. Divide by 2 to get -1/4, and so on and so forth. So the long and short story of why the 0 power rule works is it fits the pattern. There is a little bit of a more mathematical explanation that if this is something that you're interested in, I encourage you to go seek out those videos online. Okay, so just to recap, okay, our rules of indices or our rules of exponents. Okay, these apply for when we're talking about non-zero bases. If we have a 0 base, everything's 0, so none of these rules really apply. Okay. So we have, I'll label these, the product rule, the quotient rule, the power of a power rule, the 0 power rule, the negative exponent rule, and then this last one we haven't really talked about, but this last one is called the rational exponent. The rational exponent or rational indices. Okay, so what that means is if you have a fraction, okay, x over y, the denominator is the index of your radical, and the numerator is the power on your number. Okay, that will come into play as you get later on in your. It'll come to play a lot again as you get later into your mathematical career, looking at calculus and those type of problems. But let's look at a specific example real quick. So a to the 3/5 power is the 5th root of a cubed. Okay. So that is your recap of your indice rules. So we looked at the properties of exponents and some specific terms that go along with